Hi, just doing one quick example question. This force equation we didn't quite get to in 1A. I'm just going to show one example of this calculation. These are two charged particles, them being positive and negative. We know that they should attract one another. It's an attractive force, and we did that in class. I'll write down the force equation first. F equals K Q1 Q2 over radius squared. The K is a constant, which is 8.99 times 10 to the ninth. Think of that as the conversion factor between charge and force, which is measured in newtons. Q is the amount of charge on each object. Notice that these are in microcoulombs. We're going to have to change those to coulombs in R. R stands for radius, but this is really the distance between the two charged particles. All right, so again, it's a positive and a negative, so they're going to attract. I'm going to write in the K, 8.99 times 10 to the ninth. The two charges, 5. Now micro. Micro is times 10. Let me write it this way. Micro is times 10 to the negative sixth, 5 times 10 to the negative sixth, 6 times 10 to the negative sixth. Oops. And finally, divide by that distance squared. All right, so let me pull up my calculator to show this. In my calculator, and bring back the screen. All right, so I'm going to type in 8.99. Now, many of you have been doing times 10 to the negative 9 power. I highly recommend not doing that. We're going to do 8.99, then I'll hit second in the little e, times 10 to the ninth, times 5, e negative 6 times 6, e negative 6, divided by that distance squared, 0.01 squared. And I get a force of about 2,700 newtons. And now, in the WebAssign, you're going to use this same problem. It's just asking to solve for the force between two objects. So I'll write down equals 2697 newtons. Keeping in mind Newton's third law, the force applied to each one is the same according to Newton's third law. Whatever force this guy gets from the negative gets from this guy. And I think that's it. Thanks.